Hello everyone, I'm Yansheng. This video is for the oral presentation assignment of Mate 7015. Now I'm going to start my presentation. The topic today is the methods to reduce residual stress in SLM process. First, let's review the concept of residual stress. Residual stresses are stresses that remain in a solid material after the original cause of the stress has been removed. When a material undergoes a phase transformation, the volume difference between the newly formed phase and the surrounding material causes expansion or contraction of the material, resulting in residual stress. Residual stress can result from a variety of mechanisms, including plastic deformation, temperature gradients, or structure changes. As this kind of stress can be produced in variety manufacturing process, its effects may be desirable or undesirable. Today's topic mainly focused on the residual stress in selective laser melting process. Selective laser melting technology is a typical additive manufacturing technique which uses a high-energy laser beam to selectively melt metal powder layers to produce high-density components. The production of this process is expected to have lower porosity and better mechanical properties. However, as SLM process uses a high-energy laser beam as the heat source to scan the powder layer, such local heat input causes uneven temperature field and local heat effect, which makes the molten pool prone to generate residual stress during solidification and cooling process. In the solidification process, the metal powder near the center of the high-energy laser beam is heated rapidly at a heating rate much higher than that of the surrounding area, so that molten pool is formed. The formed part affected by the heat expands, and the thermal expansion deformation is constrained by the surrounding, resulting in the generation of elastic thermal stress. In the cooling process, the thermal shrinkage occurs when the molten pool solidifies, and the thermal shrinkage deformation is limited by surrounding, leading to the local tensile stress. Correspondingly, residual stress will be formed at the lower part of the molten pool to balance with it. As you can see, the existence of the residual stress will not only affect the dimensional stability of the component, but also reduce the yield strength, fatigue strength, and corrosion resistance of the component. How to reduce the residual stress in the laser additive manufacturing component without reducing its performance has been one of the focuses in laser processing field. Today, I'm going to introduce 4 effective methods to help to reduce the residual stress in SLM process. As this manufacturing process is a very complex process, there are many factors that can affect the residual stress in the manufactured component. The first method is focusing on optimizing the process parameters to help reduce the accordingly residual stress. According to the research, the most essential parameters that could affect the magnitude of the residual stress are laser power, scanning speed, hedge spacing, and powder thickness. According to the experimental research, with the increasing of laser power, the temperature gradient increases, and the residual stress generated during cooling process also increases. Therefore, the residual stress can be effectively reduced by selecting appropriate laser power according to the property of the material. Scanning speed refers to the distance that the laser beam moves per unit time. Contrary to the effect of laser power, the results show that the residual stress in SLM components can be reduced by increasing the scanning speed. Hedge spacing means the distance between two adjacent parallel lines in laser fusion. With the increasing of distance, the temperature gradient decreases, results in the residual stress drops. Also, as powder thickness increases, the residual stress could be decreased by reducing of the cooling rate. It can be seen that the scanning steps can directly affect the final residual stress of the whole process. As a result, the applied scanning strategies should also be mentioned. The most common strategy used in SLM are line scanning and island scanning. Comparing to the traditional strategy, the island scanning strategy is considered to be the most effective one to control the residual stress. The island scanning strategy subdivides the powder layer into smaller square areas. In the scanning process, each island can be regarded as an area where the scanning strategy can be selected independently. Generally, the scanning directions of adjacent islands are perpendicular to each other, so that each layer of powder has a track that sweeps along multiple directions, so that there is no principal stress in one direction, thus reducing the anisotropy inside the manufacturing components. Then, let's move to the powder bed preheating methods. This method uses a particular equipment to preheat the forming area during processing, which could significantly reduce the thermal gradients during the process. However, the temperature is limited to about 200 degrees due to the mechanical design and operation challenges. At present, this method is still considered as one of the most effective methods to adjust and control residual stress during SLM process. Another method is stress relief annealing. It is a heat treatment in which the metal is heated below the recrystallization temperature to remove the internal stress, but still retains the effect of cooling and curving. When the process is carried out, the residual stress of the forming component is relaxed by local plastic deformation and at a certain temperature. This process cannot completely eliminate the residual stress inside the component. To do so, the component must be heated to a higher temperature, but it will cause the change of microstructure. Therefore, the stresses relief annealing process needs to select the appropriate heating temperature and holding time according to the material properties and the shape of the components. The methods introduced below are available to use at present. However, the researchers would never stop to develop new methods trying to reduce the residual stress more efficiently. I'm going to introduce a new method discovered by the researchers which could help to reduce 90% of the residual stress. The method was discovered by Lawrence Livermore National Laboratory in the United States. They irradiate the surface with DDoS. It starts at full power and immediately decreases within 20 seconds. This method raises the temperature rapidly and slowly to cool the powder bed in a controlled manner, thus reducing the residual stress efficiently. The researchers plan to follow up with more in-depth studies, turning their attention to increase the number of layers per heating cycle to see if they can reduce residual stress to the same level and try to apply them to more complex parts processing. To conclude, SLM manufacturing process is an unsteady and transient process. Local heat input will lead to uneven temperature field, which will leave a larger residual stress inside the forming component. the key method to eliminate it, including optimization of the key parameters of the process, using better scanning strategies such as island scanning, applying post-process methods such as powder bed preheating process and stress relief annealing process. There are still some new methods coming out to solve this problem in the future. Okay, that is the end of my presentation. Thanks for listening.